I'm just going to give a little bit more background here in terms of this assessment approach, and this is what's in the document. So it's all fine to have a tool, but we wanted to also put a context on that. And so there are three major elements to having to apply this. One is you're going to have to supply the tool with data. The computation needs data, and you need a conceptual model, so you have a decision basis that you feed this calculation approach with. And then you need to put that into the context of a decision. So the goal behind the guidance document was to kind of walk through that whole process with the idea that if you follow that, and you follow that in conjunction with your both the site owners and the regulators, then you have a discussion basis. You're able to look at that, say we've walked through this process, and here's the calculations, how they came out, and now we can make a decision. So in that tool, it kind of follows this basic flow chart. And so it starts with data collection, moves to the conceptual model, looks at the regulatory aspects. We had an EPA co-author on this that helped us with that. It moves into the calculations and then on into the decision document. And so the first big element is really this conceptual model. And the reason we think this was really important to put in the document is because your conceptual model may be quite different when you're doing this performance assessment than it was at the onset of your installing the SVE system, because you perturb the system. You run SVE for a while, you learn a lot from that, so we talk a lot about that. And the key is that we're trying to, one, do what you might think of as a standard conceptual model, but we're also trying to get into a framework that supports the calculations. So this figure here on the right-hand side is our basic conceptual model that shows how we need to take that site and describe it so that it fits into how we're going to do the calculations. So that's going to be a big part about what we talk about today, is how do you translate site data, which might look at, you might have cycled your SVE operations for a while, or you might have a distribution of vapor phase concentrations. How do you take all that and other information and put it into something that describes the site in a way that you can then estimate transport? So that's one big part of it. And there are a couple of kind of interesting elements about this. So one is the source configuration. You know, if you noticed on that previous slide, of course, not all sources are these perfect rectangular cuboids, but we did quite a bit of work to look at, well, we know that sources are distributed in different ways in the subsurface, but how can we make some generalizations that still work for transport calculations? So Mark's going to show you some of the things that we did to try and make it as relevant as possible. In terms of source strength, there's a couple different ways you can look at that. You can obviously measure soil vapor concentrations, but because you have an SVE system at the site, you can measure mass discharge. You can use your SVE system to therefore give you a different way to quantify that source. And so we have both methods of quantifying the source in our document and in our tool, because they both may have advantages at different types of sites. So this is like your classic rebound analysis and how you might use that. Source location is also important, because that's the context of where's your source in relation to either your surface or to your groundwater. What are those distances? How is your source configured in the subsurface? And so there's also information in the document that talks about, well, you can use vapor phase concentrations, but again, because you have an SVE system, there are tomographic methods you can use. And so throughout this handout, you'll note that I've got some references listed down at the bottom. So we can't go over every little aspect of that, but there are a lot of publications that support, for instance, using this vapor phase tomography to help you get a better measurement of where that source is. So we gave you the references. We'll talk a little bit about that, but most of this time will be focused on how do you take that sort of data and get it into this tool and this calculation. But there are some really nice things that you can do given that you have that soil vapor extraction system at your site. In terms of the next component, which talked about the regulatory context, again, we worked with EPA on this, so we talked through some of the common things that you really are going to have to pay attention to as you're working with your regulator and gathering information and then putting that forward into a regulatory document. Establishing what those exposure pathways are, what your receptors are going to be is important. And I think the main thing for this class is to realize that, while we may have these different exposure pathways, what our document and our tools really focus on are either that vapor intrusion pathway or that groundwater pathway. Of course, you still may also have that direct exposure that you have to consider, but we're really looking at ways to quantify transport, and that's our focus for this. And for that, of course, is our calculation portion. So in the calculation portion, this is where we're going to talk about these tools, but it's important to recognize in the document that you have to think about that in the context of your site conceptual model. So we have to walk through and characterize our source in terms of its location and strength, and then we have to think about that also in the bigger context. So we have kind of these three different types of sites. So the first type of site might be a site where you just have a strong VIETUS zone source, and you know that's your main driver for risk at the site. And so you're going to want to look at transport out away from that source. You may also have a site which we call type 2, where you have not only that, but you have some existing groundwater contamination. So that you have to take that into account when you're looking at the risk from that remaining VIETUS zone source. So we'll talk about that in some of our case studies, but it's a little bit a different dynamic. Now you have to realize that some of your vapor concentrations may be coming from the groundwater. And for a type 2 site, we categorize that as where we still have a dominant transport from the VIETUS zone to the groundwater as our primary movement for contaminants. The type 3 site is a site where your groundwater contamination is so high that you actually have vapors coming upward. And so these are the contexts that you have to think about, because our calculation tool, we have to make some assumptions, and then you have to fit that into what type of site you have. So the document kind of walks through that in more detail. Most of what we'll talk about today are the type 1 sites, how do you do those calculations, but in our case studies we'll show you some examples where we've dealt with some of the other types of sites and how you can still go forward with an analysis, but it's in a different context. Vapor intrusion, like we talked about for VIETUS, and then in doing calculations, we have to think about what are our baseline assumptions. So in what we present, we talk about how do you make a decision that's going to be valid for the long term. And to do that, you make assumptions like, well, if this source were to stay the same forever, what would its impact on groundwater be, for instance? And so you can make that calculation, and that's the basis for the spreadsheet tool. And then you may realize, well, that's not going to happen. We're going to have some source decay. And if I can quantify that decay, then I can run my tool multiple times to see how that concentration may change over time. So we have to do certain things like that in order to deal with things like source decay. Other common questions might come up about, what about sorption? How do I incorporate that into the equation? For our long-term assessment, actually, we neglect sorption, and Marta will describe why we made that selection. You may have other attenuation processes, either in the VIETUS zone or in the groundwater. Those are some extra things you'll have to think about in terms of using this tool, but we'll have to realize, and as we go through this course, there's certain limits, there's certain bounds to what the tool does, but then if you can still use it as long as you're thinking about how you use it in these contexts. So here again this is the primary conceptual model that we're going to be talking about here today. These are in the simulations we've done, these were determined to be sort of the primary driving factors. So if you can parameterize your site with these, this will give you the basis for what we think is a good way to estimate long-term transport. So we'll talk about the basis for that here next and why that is important. In terms of a couple of these sort of special case items, I did want to talk a little bit about the source decay. So this is a site where here on the left-hand side, they had run the soil vapor extraction in sort of a constant mode for a long time. They reached a point of diminishing returns. Then they actually run it in cyclic mode for a long time, almost 20 years. And they had a lot of mass that was still coming out over time, but then that diminished. And so if you look at the plot here on the right-hand side, this is a log scale plot of the diminishing mass discharge from that source. So the cleaning out the permeable portions of this site was diminishing what was remaining in this persistent source. And so we know that process is occurring, and it's being accelerated by soil vapor extraction. If we shut it off, that's still going to occur. We know we're still going to get source decay, but at a smaller rate. And at this site, we estimated that rate would be about 5 times less than the rate of what it was during soil vapor extraction. And the way that worked was we said, well, in this top plot, we know that if this zone in the middle here is our primary remaining source that's causing this mass discharge, we're essentially cleaning out these higher permeability zones both above and below. So we did that periodically. Once a year, we'd run it for 3 or 4 months. We'd clean those out. Now we've created essentially an enhanced diffusion situation for mass coming out of this middle layer. When we turn off the soil vapor extraction, mass is still going to diffuse out of this layer, but now the boundaries are moved further away for that diffusion process, right? So now it's still going to have a zero concentration boundary at the surface, but we haven't, that's a less of a diffusion driver than what we had during soil vapor extraction. So you can still make these estimates on what your source decay can be and plug that into your calculations. So I just wanted to bring that up as sort of an example of a way that you can take a construct of how the model's configured, but still take into consideration these other factors at your site and use that as a tool. You just have to use it maybe multiple times or in conjunction with other calculations. And then the last piece of the document is talking about how you put this into a decision document framework. And the best way to describe that will probably be a case study, but I do have a case study where we've taken this and used the document, and then we made a site-specific flow diagram for it and said, here are the big things we have to take care of, here are the decisions we're going to make along the way. The regulators and the site got together, they signed a document, said, yes, this is how we're going to do it. We did the process, and then everybody knew that was what we're using. We got done with the process, and the regulators said, okay, we've gone through, we checked all the boxes, and we're ready to stop. So we'll go through that as a case study, but it is important that we have that sort of negotiation thing that we bring into this process of how we use these tools. Let's talk a bit about some of the limitations. And we brought up this earlier. So this calculation tool is like any other model. It can't do everything. So you always are going to have those limitations, and you need to discuss those among the project team. And it depends on whether you have some incremental variations versus significant variations, but anytime you step outside the box that we've identified, you're outside that interpolation range from those three-dimensional simulations. So again, you have to be careful each time you go out this, but you might have certain issues that come up where you're going to have to make some decisions. So here's this first slide shows you, in terms of the source configuration, you may have a source that's a little bit closer or further away from the groundwater table, thicker or thinner, different lateral extents, and that's where, going back to some of that technical information, which is in the document, by the way, you kind of see which of these parameters are pretty nonlinear, and so you have to be very careful when you go outside that. But again, you could make a decision like we used with the source location, where the RSP value was 0.08, and with a small variation in that to get inside the bounds, you might say, okay, within the certainty we know that value anyway, that's okay to modify that. So these are some things you need to think about for limits. So that source configuration is sort of an obvious one to think about. Things like porosity and bulk density, those actually you can't change in SVEET. They're all based on set values. We actually are working on allowing that in hopefully an upcoming version. But some of the reason we made those set is because they didn't have large variation for most of the simulations that we ran. So some of these things are things that aren't variable because they don't make a large difference when you're within our limitations. So again, hydraulic parameters, you'll have to think about those for limitations. And in the groundwater, a couple of the elements that might come up is where your compliance point is relative to what is allowed in SVEET. And one thing to remember is that SVEET has a simplified groundwater transport component. We don't have attenuation factors in there. We have one set of dispersion. So you have to think about, the further you get away from the source, the more you might have groundwater dynamics that matter. And so that's why we've constrained this to only a certain set of distance. So this is really a near source sort of estimating tool. So you might, for instance, need to couple this with a groundwater model if you're looking a long ways down the line for compliance. And then of course, like I talked about earlier, you may have to consider when you have existing groundwater contamination. So that is going to, SVEET assumes that we got a clean groundwater that we're contaminating from the VIETUS zone. And actually, that's been of use, and we'll talk about this in a case study, because then you can say, well, once we clean up the groundwater, this is what the vadose zone component is, and if it's not going to contaminate the groundwater above a limit, then you're done with the vadose zone. So that's why we did that. So I just want to make sure we brought up some of those issues, because those are some typical elements that might come up, because we only have a certain set of parameters we can look at. And if you have a vapor intrusion sort of need, VIETUS uses the same sort of input for parameterizing your site. And so everything we told you about is all the same. In VIETUS, we did make some additional constraints, because there we're not just looking along the center line for groundwater, we're looking at a spatially large set of vapor phase data that is the output. So we had to impose some limits, because it's, what is it, Chris, 150 megabyte
150
data
megabytes
file.
worth of data, yes.
So you can't change recharge. When you look at concentration data, it's a little bit different from SVEET. You can't vary the thickness of the screen and those sorts of things, because we're giving you a data value in the groundwater, really mainly for your information, because it's the gas phase that you're interested in. So in the documentation, it tells you about some of those factors, but just the key is it's the same internal guts of the simulation results. It's got applied for a gas phase concentration, but make sure you kind of familiarize yourself with both the SVEET and the VIETUS if you're going to use them in combination. But this should give you a good start with that.